Okay.
Whatever the HTML using forms are we creating on the front page, all these things are comes under the presentation layer. Second, whatever the business logic in a form of program we write, everything is called programming layer, the business logic layer, or it can be a programming language is being used here. Now, the third one is called data layer. Means if you want to store any kind of data, for example, here you have given some information, there must be some data has to store somewhere. Where it will store? This is where generally you require some data layer here. Now, these three layers are developing under a single platform. This is where generally we call it as single tier architecture. This is where we call it a single tier architecture. I'll give you an example to you. These are the three layers will be there in the application. Do you agree with this? Right? This is agreed. Now, let's say if you take Excel. Excel is also an application. You know that, right? Now, Excel is an application. If you take as an example, whatever the layers I discussed with you so far, either it can be presentation layer, or it can be business logic layer, or it can be data layer. All these three layers are developed under the single platform. Am I right? Yes or no? Why? Because, for example, if you open an Excel sheet, presentation layer, for example, if you want to give some calculations, you can give the calculations on the screen itself. Yes? Right. Second, business logic layer means if you want to add all this, you can do the calculations there on the screen. You don't require any other screen or other support application. You don't require to do the calculation. You can do there only. Data layer means whatever the data you want to store, are you using any database to store the data for Excel? Are we using anything? If you want to use the Excel sheet, is there any database you require? Any Oracle or Sybase kind of database you require? We don't need it. Yes, sir. No. Whatever the data you are writing, everything data will be stored on the Excel itself. Am I right or not? Right? So, whatever the three layers are we talking about, either it can be a presentation layer, or it can be business logic layer, or it can be a data layer. All these three layers are developing under the single platform. Single platform. Okay, this is what generally we call it as single tier architecture. I'm coming to architectures now. Okay, now you will be knowing well. You will be understood well now. This is what we call it as single tier architecture. Single tier architecture means whatever the three layers of the application as we discussed so far, all these three layers will be developed under the single platform. This is what we call it as single tier architecture. Okay, clear to you? Understood? Yep. So, next. Second, for example, there will be some other applications. Those applications we call it as two-tier architecture applications. Two-tier architecture applications. What are two-tier architecture applications? Let's say, for example, you are working for an organization or someone is working for an organization. That organization consists of some 10 workstations, 10 systems, 10 different systems are there in the organization. 10 people are working, 10 different people in different roles and all, they are using the systems. That there belongs to some business, some financial institution, something. Now they are using some application to perform their business activity. This application, from where they are accessing it, this application they are accessing from the local server. From the local server, not from internet. Not from internet. It is from the local server. Local server means in that particular premises, server located somewhere. That server is connected with all these 10 workstations through LAN connection. Okay. If a server administrator, whoever is the server administrator, if he is not given any login credentials or login support acceptance, if he is not given, these client systems cannot use the application. Am I right or not? Yes or no? Right. Agreed, right?
Yes, yes.
So when you are developing an application, see, this is all something relating to the technical perspectives. Please do remember. Okay, again, I'll go back to the microservices from here. You will be knowing well. So two-tier architecture. Two-tier architecture means you have two systems. One is client systems. Second is the server system. So when you talk about presentation, business logic, or data layer, these are the three layers you have to develop in two platforms. What are the platforms? You have to develop in the server platform. The same thing you have to develop in the client platform also, because this is what we call it as two-tier architecture. Understood?
Okay.
Clear to you? Understood?
Okay.
Right?
Yes, yes.
Next, entire at the same time, three-tier architecture, cloud architecture. There are a lot many. I am not going there. Okay. Three-tier architecture or entire architecture, something like that. Three-tier architecture or entire architecture, all about is, let's say you are using some web application. The best example is web applications. For example, you want to order some pair of shoes online. So you are going to the internet, you are searching that website, whichever the website you want to order the goods, you are simply searching it. You are sitting at your home and you are ordering it. Server located somewhere. By just giving some URL, some so and so xyz.com, if you can give it on the internet, automatically that website will open to you. That portal will open. And whichever the goods you want, you can select the goods, you can put it in the shopping cart and you pay the money, so that in next coming 2-3 business working days or so, you get the goods to your doorstep, right? This is what is happening. So here, do remember, server is not something located here. It was somewhere there outside. You don't know. But how you are accessing that data? You are accessing the data through an URL. Make sure if you want to work on that URL, you require some internet. Agreed to you?
Yes.
Okay. Yes, sir. Right?
Yes.
So there will be 3 layers. There could be more than 3. That's what we call it as entire. Entire means more than 3 layers also you will be having. So when you are going to develop any application, there are different type of applications we have. Some are standalone applications. Some are client server applications. Some are web applications. Web applications means 90% whatever the applications we use nowadays are web applications, right? All these are web applications. Some are nowadays is called cloud applications, cloud architecture. Cloud application means you don't require any software to be installed in your system, being a user. What you can do, simply there will be a user ID password will be given by the cloud service provider. Simply you log in, use the application. Whatever the services you want, every services will be there. Either it can be infrastructure service or it can be a platform service. Or if you want to use a software, every services will located there. Being a user, whatever the services you want, you can use it.
Okay.
Whatever you are using, you can pay for that. Pay-per-use kind of stuff. Okay, pay-per-use kind of. This is what generally we call it as cloud services application. So this is what, these are all comes under the cloud architecture. So here, if you see, whatever the explanation I have given you for last couple of minutes, more than 10-15 minutes, if you see, architecture is a word which is common everywhere. Yes or no, right? Either it can be single tier, or it can be a 2-tier, or it can be 3-tier, or it can be multi-tier, or it can be a cloud applications. End of the day, if you want to develop an application, you have to create an architecture.
Right.
Yes or no? Right? So now, this is where generally architecture styles come into picture. Normally, architecture styles in nowadays will be classified into 2 different parts, which is trending and easily understandable for the people. Generally, styles of architecture will be 2. One is monolithic architecture.
Okay. Yes, monolithic architecture.
Second is microservices architecture. Second is called as microservices architecture. Now, what is the difference? You can ask me one thing, Raj, how is it different? What is monolithic? What is microservices?
Right.
1 minute, I think here. Okay, what is monolithic? What is microservices and how is it different? Monolithic means, I'll give you a simple example. Before I am getting into IT application, I'll give you a generalized example. We know how cars were manufactured, right? We know. In the olden days, long back, very long back, if car was built, normally that time cars used to build using using iron, all that, right? So that's not something like a fiber kind of, right? Mostly iron will also be used in that. That's how earlier was.
Right.
Now, if you see in the olden days when car was manufactured, the complete body is completely tightly coupled. Yes, tightly coupled. For example, if car was met with an accident, for example, some bumper was somewhere met with an accident, in the olden days, you used to repair and you used to change the complete part of it. Am I right? Yes or no?
Right. Right.
Why? Because if you have seen a car as a manufacturer, whatever the components they have used, these components are tightly coupled. Means if there is any damage happened for a car, for an unfortunate situation met with an accident or something, if you want to change a particular component, you have to change the entire structure. Agreed? Yes.
Right.
But nowadays, whichever the part was damaged, you can simply change the part without having any disturbance with other components. Am I right? Yes or no?
Yes. Yes.
This is what generally did the difference between monolithic to microservices architecture. I'll tell you the reason. Earlier in the beginning days, if customer used to give us the requirements to develop an application, there won't be much volatility in requirements. For example, you have developed the applications, any changes required may happen maybe in a year or more than that. Usually that was the situation earlier. So there is no volatility in changing the application or the requirements in a shorter time. There was no need that time in the olden days. But nowadays, the situation was not that. For example, you are developing some e-commerce application. Whatever the requirements customer has given today may not be there by tomorrow. Am I right? Yes,
Right.
sir. Point number two. This is one. Point number two. For example, you have built an e-commerce application to one of your customer. After 3 months or after 6 months, your application will get outdated. You
Right.
have to change it every time because depends on the market need, depends on the market requirements. You have to make the changes in the existing application all the time. Am I right? Yes, sir.
Right. Yes. Yes.
Now, if you are a technical person, do remember as an application, if you called, which are having lot of components or features we called, if all these components or features are tightly coupled, if you want to make changes in a particular component, when it is required, what will happen? The remaining components will get affected. Point
Yes.
number one. Point number two. If you want to do the testing, what you have to do? You have to do the testing right from the scratch. Now, is there any guarantee that changes will be only one and two in limited time? No, there is no guarantee because requirements can come at any point in time, and we have to make the changes at any point in time. Am I right or not? Right. So earlier in the beginning days, and of course nowadays also we are following some companies, still we are following monolithic only. Slowly we are coming out from monolithic and we are using microservices. That's a different context altogether. Earlier, what used to happen when you want to develop an architecture, the architecture is a monolithic architecture. This is how generally the difference you see.
Right.
You can see, can you see this? These are the two differences you can see it here. One is about monolithic approach. Second is a microservices approach. Whatever the
Right.
layers I discussed with you so far, either it can be a presentation layer or it can be business layer or it can be a data layer, whatever it can be. In monolithic approach or in using monolithic approach while we are developing an architecture for the project in monolithic, remember, whatever the components are we using are tightly coupled. Means if there is any flexibility you want to make in between due to the requirement changes or volatility, it is really difficult for us to make some changes in between. So what used to happen nowadays, the problem is nowadays is that as in when volatility of requirements are changing from time to time, according to the need of the customer, you have to address and you have to change your model. That is how we have to adopt, right? So you have to do that adoption faster. So then we will be in the race. Otherwise, we'll be out of the race very soon. So monolithic here, it was a monolithic approach, as I stated. In monolithic, what happened, whatever the approach are we talking about, or whatever the process we have discussed with you so far, these components are tightly coupled. Because
Right.
of the components which are tightly coupled, what will happen if there is any kind of changes you want to make in between? It is really difficult. For example, it is complex to change or to make some changes in between. First of all, complexity more, effort more, operational cost, timelines will also be more. Apart from all, above than all, you have to do the testing right from the beginning. Right from the beginning, you have to do end-to-end testing all the time. How long you do this? Because you don't know when the requirements changes. That's the reason why nowadays we are coming up with some microservices architecture. What is microservices? Microservices is an architecture, is a style of architecture, I can say, architecture style, you can call it as. The microservices is a style of architecture. Whatever the components are we using nowadays are loosely coupled. Means whatever the component you are developing, for example, whatever the module or the feature you are developing, for everything you are developing a separate microservices as a component, a separate thing. Okay. So if there is any kind of change you want to make in a particular component, without having any disturbance with other applications, you can do the changes. For example, there are some banking applications, some core banking application we have developed. We have given this to the customer. For example, customer want to make some changes in the CRM process or maybe in the ERP process. For example, right, which are interconnected with other applications. Now you want to make some changes in between. If you want to make some changes in between, what is that you have to do? You have to address the specific problem. Till the time you cannot instruct your users to not to work on the application. You cannot say that because this is an application, they have to do it on day-to-day basis. They cannot stop in between. Agreed? They cannot stop in between. So that's the reason what they have to do. They have to make the changes in the existing application. Only specific possible, specific module or specific component and all, they want to do the changes. So without having any disturbance with the other application, this component can be replaced or modified. Subsequently, other application will continue as usual. This is possible when we are following the microservices here. Understood? Clear to you?
Right.
Understood? Right? Now, coming back to the point, when it comes to the difference, again, I'm coming back to the difference when we are talking about the difference between 9 and 10, right? TOGAF 9 and 10. 9 and 10. The first one about, as I mentioned in the beginning, again repeating the same, one is about agility. This agility can be an enterprise agility, or it can be a business agility. Okay. Right. Point number one. Point number two, major change you see from TOGAF 9 and 10. When you talk about 10, one is agility, point number one. Second, introducing the microservices architecture. Understanding over the microservices architecture is also one of the key and important element wherein added here. Microservices architecture is also added. So one is about agility, enterprise or business agility was added. At the same time, microservices architecture is also added, right? I think what is microservices? I hope you got a clarity, right? What microservices is all about. So the detailed part, what are the advantages, disadvantages, that I discuss with you when time comes, not here, okay? Point number two. The third one about the digital strategy. Digital strategy means whatever the model are we adopting, especially when we are implementing TOGAF? Nowadays, what is that we are doing? We are making a digital content. We are going towards the digital direction. This is where generally digital transformation, I can say, simply called as digital transformation, is what something we are going. So why are we moving towards digital transformation? Because you want to make TOGAF implementation more easier. Normally, people have some misconception, which is not true. In fact, most of the people, some of the people may think that TOGAF implementation might be something difficult. So when it is difficult, when we have not understood the right core concepts of TOGAF, then it is difficult always. So when you
Right.
understand the right core concept of Agile, followed by the methods of Agile, as well as the kind of principles what I've told you, right? So what are the different parts of TOGAF? If you understand about architectural development framework, or if you're trying to understand about the architectural governance, or if you're trying to understand about the guidelines and techniques, right? So if you know about these well in advance, either it can be capability framework, whatever we're talking about. So as long as if you are very strong in these areas, it is not so difficult. It is not so difficult. It is a misconception. But what TOGAF has done earlier, when you are comparing from 9 to 10, what 9, 10, what they have done is in 10, they made it very simple and they made it more easier for the people who wants to implement TOGAF in the organization level by implementing the digital strategy also. Digital transformation, I can call it as. Digital strategy or digital transformation is what something which organizations have implemented. So these are the three major changes you see when we are comparing from 9 and 10. One is about agility. When we talk about enterprise agility, business agility, all that. Point number one, which you don't see it in 9. Point number two, detailing and discussing more about the microservices architecture, because TOGAF is also part of enterprise architecture. Okay, when you are implementing enterprise architecture, TOGAF is one kind of framework we are using to build, construct, design, to maintain, right? So for the enterprise architecture framework, TOGAF is being used. That's the reason why understanding over the microservices architecture is added. At the same time, third one, it's not the final one, which is called digital strategy, is also included. So these are the 3 points which were included when you are comparing from TOGAF 9 to TOGAF 10. Clear?
Okay, got it.